Welcome to From Cover to Code, the Technology Book Club. Join us as we discuss artificial intelligence, DevOps, software development, cloud computing, and more. With your hosts, Angela Andrews and Michael Jenkins. The next episode of From Cover to Code starts now.
And we are live and in the building. How are you doing today, Angela?
I'm doing so well. Happy to be here. How are you doing, friend?
I'm doing wonderful. I had a opportunity to go to a really cool concert last night. I saw LMA live at the Greek Theater. It was a wonderful show.
Okay.
Yeah, so really enjoyed the concert, albeit it, I got home late, had to get up early, go to work, and then run from work into the studio to be ready for this discussion. But again, as I've said before, this is a totally a highlight, so I'm ready and raring to go.
I love it. I'm sure she sang my song. One of these.
Which one? One of the that was in the set list. Indeed, it was fifth or sixth song in the set list.
That is my jam. I'm sure my husband is sick of it, but I don't care because that's my song. So I'm glad you had a great time. Yeah, but we're here now.
We are here.
It's just nice to be here. So,
yeah, indeed.
Listeners, thank you for joining. Viewers, if you're there, thank you for joining. If you're catching this stream at a later date, it is a wonderful day weather-wise where I am. He lives in paradise, so I'm sure it's beautiful where he is. And I hope wherever you are, it's beautiful. You're not dealing with too many weather issues and, you're enjoying your time with us. So let's get into it.
Yes, indeed. Yeah. And just, to follow what you said, shout out to the folks on, as I always say, MySpace, Facebook, Instagram, Google Meet. I don't know, wherever you are, Zoom, I don't know. Wherever you might be watching this, thanks for catching up with us. We are still running through and like close to the end of Terraform Up and Running by Jim Brikman this week. And Angela's got her paper copy. I'm still on my Kindle and digital copies as I hold up my phone, and my PDF is here on my computer. We are this week going through chapter 8, production grade Terraform, where Jim walks us through a discussion of building modules that you can bet your company on. So he's got some good tips in here.
That is actually a quote in the book.
That direct quote. Yeah. He said it twice.
He meant that. He meant business when he said that. So
no doubt. So that's where we are picking up. So where do you want to start on this thing?
I don't know. What does production grade mean to you?
Production grade to me, that's I think that's probably the best question to start this discussion with. It means to me something that's going to run reliably, or something that's going to be useful to more than one person or group or thing. Like it's not some bespoke, one-off, handcrafted piece of code. It's something that's packaged nicely. Okay. And when you hand it to somebody to run, however they run this code or whatever it is, it runs reliably, dependably, repeatably. So that they can expect the same performance out of it over a long period of time without, any sort of nebulous operations, things going on. What about you?
Well, production grade is, even if the code is running in production, doesn't make it production grade. You used the catchphrases that make it production grade, repeatable, clean. A topic that you're going to hear a lot in this chapter is modular, right? So production grade Terraform code takes into account the various environments that you're running in. It takes into account the various users and access that you may have for one environment over another. Um, Production grade means a lot of things, but it's definitely the modularity, the repeatability, the clean code, the tested code.
Test.
Yeah, so that's what I think it is.
Okay, cool. No, that's a good baseline to start from. And I think with that in mind, like he starts the chapter off with this discussion of this production grade infrastructure checklist. Well, even before that, he talks about how there's this mindset where people are maybe too optimistic about how long or how little time is going to take to build something that's production grade. And then come to find out they have to do X, they have to do Y, they have to do Z. And he gets into this term called yak shaving. They realize that they're shaving a yak in order to build that. And for folks who don't know the concept of yak shaving, just a quick discussion or explanation. You start out to do one thing, only to realize you have to do another thing. When you start to do that other thing, you realize you have to do something else. Then when you start doing the something else, you have to do yet another something else. So then you start to do yet another something else, and then you have to end up shaving a yak, basically. So that's where the term yak shaving comes from. And there's a whole like initial explanation for it. Maybe I'll put the link to it in the show notes. But basically, you have to go through all these different tasks just to get this original task done. But that might be how many days or hours later, so, and that those sort of diversions slow down your progress. So he talks about, these different types of services. Somebody might deploy a managed service, a self-managed distributed system that's stateless, a self-managed distributed system that's stateful, or an entire architecture of apps, data stores, load balancers, monitoring, et cetera, going all the way from maybe 1 to 2 weeks for that first thing, all the way up to 6 months to 3 years.
Yes.
Last thing, once you finally realize all the stuff that you're doing.
All the things. So I do think people don't quantify the time it takes to deploy and develop. There's a lot that goes into it. And one of the analogies was like, if you're talking about your entire infrastructure, I'm talking about step 0 into, multiple environments, security alerting, monitoring, observability, scaling, the whole yes, that could take you 3 years because, and we're not even talking about the code part. We're not talking about writing the Terraform code or the CloudFormation code, the Ansible code. We're not even there yet. The idea of building out something requires a lot of planning in the beginning to get it right. And you know what I mean? So that I think that's why people, this is so easy. Yeah, it's easy. I've spun up entire architectures in AWS. But are they production ready? Are they real? Are they absolutely not? I'm not taking security into consideration. No. NIST who? Like I'm not doing anything I'm supposed to do.
And socks what?
Lucky, right? You lucky my credentials are hard coded. So it is a lot. But this chapter takes us through I want to say why it takes so long. You have to understand it. And then this is how Terraform can help with the IAC part of it. It makes that part a little bit easier because you can have multiple environments, but if you're modular, the code that you write in one can very well run in others. And the code that we've been working with in these chapters is just that. It has a stage environment. It has a prod environment. And once it's modularized, you can use it across any and all environments. So yeah, that's where why does it take so long? He said there's 3 major reasons. I didn't iterate the reasons, but yak shaving was one of them that he mentioned. And DevOps is really
yes,
in the Stone Age.
Yeah, he said DevOps as an industry is still in the Stone Age.
Yeah, it's relatively new.
Yeah.
So it takes time. That's all.
Yeah.
That's what the point I'm making is. It takes time.
Yeah, and indeed, and I think he went on to say, like, he's not saying that as an insult.
No.
Calling DevOps is in the Stone Age. But if you consider even like some of the cloud computing stuff we're doing now, like when did cloud computing start? When did DevOps start within that sort of cloud computing window? And what I do is I look at our discipline as cloud architects, cloud engineers, whatever you want to call it, in comparison to other engineering disciplines. They've been doing mechanical engineering for
years.
Centuries. They've been doing physics for centuries. They have a very well-defined framework for how to do these things. We're kind of developing these frameworks as we go, and the technology changes all the time. So we don't have that century of foundation to build on, like, oh, we can do X, Y, Z, and we know it's going to work because, we've built it so many times, bridges, roads, skyscrapers, whatever. So yeah, we are kind of in the Stone Age, maybe the Bronze Age now. He did write this book 4 years ago. Maybe we're in the Bronze Age now. Okay. So we're kind of advancing just a little bit. We got AI on our side, we'll see where that takes us. Maybe we'll be, in the medieval times in the next 5 or 6 years or something.
We're heading in that direction.
But we are definitely going in the right direction. But I mean, to the point of all the things you have to consider, he does give this production grade infrastructure checklist. I'm just going to read the tasks down the line really, really quickly for the sake of completeness.
Oh, yeah. So buckle up.
Yeah, get ready. I'm going to take probably 2 or 3 deep breaths as I read through this list, and just the tasks, not the tools, not why you should be doing these tasks, whatever, just the tasks alone. And maybe if it warrants some discussion or some explanation, I'll add a little bit. So, because the first one is install, and like, what do you mean install? But that one, install the software and binaries and all dependencies. You're just getting started, just getting set up. You have to configure that stuff. You have to provision everything. Then you're deploying. You have to deploy your app and everything. You want to make sure your application has high availability, scalability, performance tuning. You want to make sure the network is squared away, VPCs, firewalls, domains, all that kind of stuff. You want to make sure it's secure, so you have to consider security. Then metrics, which come into observability and monitoring. You want to look at the logs, make sure nobody's hacking your stuff on the sly. You want to back up your data to make sure that you have some point of recovery. Then you want to optimize cost. You want to document all the stuff that you've done. And then for sure, probably along the way, you're also testing out everything that you're building. So this is the checklist that he's giving you. Is like, hey, before you start saying you're going to build something that you're going to sell to people, that people are going to depend on, take a look at all these things and consider how you're going to implement them. And, some of the tools that you might have to invest in to make that particular task happen and happen successfully.
So you heard that right. That was his production grade infrastructure checklist. That was a lot of moving parts. That is a lot of considerations. That's a lot of vendors. That involves maybe multiple teams, depending on the division of work where you are. So this is not a small task, but we are lucky that there is a tool that helps in that arena. And that's why we're talking about Ansible in this way for production grade code. So it's nothing to sneeze at, but it gives you something to think about, just the flexibility. And it's not just IAC, it's CAC, it's a whole lot of things, but being able to, what do they call it? GitOps, being able to have everything codified to be able to deploy, we saw in this example in chapter 8, like you can configure your monitoring as well inside. So there's a lot of moving parts, but thank you for going over that checklist, because I was just thinking about, like, wow, when you're messing around, because Terraform does make it very easy to deploy quickly, tear down, tear up, lickety split. And we usually don't even consider even half of what this checklist goes through. It makes it easy, but it also gives you the tooling to make it right to make it production grade. So I'm
Very
off
true.
my horse about that.
It's all great. Hey, we have free reign to pull out whatever horse, soapbox,
I like
pulpit, whatever you want to do. Yes, like let me grab my pulpit for a moment.
All right now.
Yeah. So whenever you want to go off track, you are more than welcome to. It's par for the course. So that's part of the shenanigans, which we always aim to deliver as one of these discussions here.
We do.
So yeah, after the checklist, he goes into production grade infrastructure modules, like you said, with the focus on Terraform. Mm-hmm. And he's saying that these should be small modules, they should be composable, testable, versioned. And then the last part of the discussion, he goes kind of beyond the Terraform module part to what he calls escape hatches, when you have to sort of bail out of some of the limitations of Terraform and the modules that they provide. So small modules, he's saying, well, I guess even before he gets into slow or small modules, he gives a comparison to a large module, saying that large modules are slow, insecure, risky, difficult to understand, difficult to review, difficult to test. And the comparison that he gives is a large function in a general purpose programming language. Great and analogy. So, yeah, perhaps we've seen this before where we get some large, super duper function that's doing everything. And like the first point of refactoring is like, no, let's break this down into some smaller functions that we can compose together, that we can test individually, instead of having to test this huge, 100, 200 line piece of code that, gives us this functionality. And it's the same point with Terraform. We just do it with modules instead of doing it with functions.
And he did mention that when you see those huge modules, kind of like, not even like the one we created, because we did have code doing way too much. And in this chapter, there is a walkthrough on how to refactor the code and make it more modular. So it'll go from what we did in chapter 6 and 7, more chapter 6, and then develop the code in a way where everything is modularized. It pulled out the ALB, it pulled out the load balancer. And that's what we mean by larger modules, cutting them down so they can be much more maintainable and consumable. And he said, large modules, hundreds of lines of code that deploy more than a few related infrastructure pieces should be considered harmful. And I get that, because we don't, people don't read anymore. Like no one wants to go through your code and try to figure out what it does. Your cockamamie README file. It may or may not cover all the scenarios. And there's a term he used in here that I had never heard before. Have you heard the term code smell?
I have heard the term code smell. So yeah, so I mean, it's basically, it's like another way to express it is the sniff test.
Okay.
So maybe you've heard the term sniff test, where you're like, it doesn't pass the sniff test. Like something is going on here, and I consider that like something that you pull out of the refrigerator. You don't know who wrapped it up. You don't know when they wrapped it up, but it's in the refrigerator, so maybe it's okay. And then you take the lid off of that thing and you sniff it. You're like,
oh no, this is going out.
There's no fuzz growing on it, but just the sniff test, it doesn't pass.
It does not pass the smell test. So that we've defined.
Yeah, so that's kind of what I talked about with, or that's what I thought about he was referring to when he said code smell.
Okay.
Yeah, and joining us live from YouTube, DB Darrell says that the term code smell is new to him.
Me too.
I've heard it used in discussion before. Okay. But I think sniff tests might be more common.
Yeah.
I don't know.
Absolutely.
Yeah.
All right. So we're getting past the point where our code is this monolithic piece of garbage that has too many moving parts in it. We're separating it out into much more smaller compostable modules. If you look in the book, on page 282, there is a diagram that shows you that could be a complicated architecture, and all of the moving pieces are said pieces are in one thing. It could be code, it could be whatever. But then you go to the next page and it says, yes, this is the same very complicated architecture, but it's much more modularized. Every piece of this architecture is a separate module, which means parts of it can be reproduced elsewhere in the environment. So there's a lot. So in going back to our code, I'm just was talking about those two photos on 282 and 283. But our example in the book on chapter 8 started off with this web cluster module, and then we broke it down into multiple, like the auto scaling group, the load balancer, the actual app, and refactored the code into an ASG, an ALB. What else? Threw some monitoring in there. So this chapter really does keep hitting home the idea of, yes, it is worthwhile to refactor in your code into much more usable modules instead of keeping everything in one configuration. This chapter is not production grade otherwise. When you let him tell it, it is really not ready for production grade if it doesn't fit that dynamic. So reusable, small, compostable, all these words.
Yeah, and the sidebar kind of benefit of doing that is if you prove these modules in one project, you could use them again on another project, and you're not starting from scratch. That gives you these Lego building blocks where you say, hey, we put the blocks together this way to come out with this solution over here. We can repurpose them over here in a similar fashion to produce, this other solution. And they've already been proven, they've already been tested, et cetera, et cetera. So it's like a flywheel for your future development. You're already headed in the right direction.
One more thing before we move on, or we can stay here, whatever. But we're talking about my brain is still on the two diagrams on the book. But this is a question for anyone who's listening, as well as you, Michael. If you do this, you use Terraform in your regular job, right? So you're using it with other teams, you're using with other people. So it's not just no one has their own code if they're working in production. But what do you prioritize? Are you trying to make it flexible first? Are you trying to make it simple first? Are you focused on making sure that you're documenting so the next person that comes behind you has a much easier lift when using your code? Are you focused on validating it to make, maybe writing in some tests and including those tests? Or are you trying to make the most performant architecture possible? And these are just words, but what if you were publishing it, what would you prioritize? What's the most important thing for you specifically?
My first answer is yes.
Okay.
All the above. Yeah. Oh, yeah. That's the tough follow-up question, right? But I like things that are composable. So I want to make sure. Well, it's hard not to do all those things.
It is. I agree.
So this is years ago, and I've heard this adage repeated by other people. But a senior engineer I was working with, I was at IBM at the time. He said, in most cases, you can work on a specification in three ways. Like you can consider time, quality, and I forget what the other one was. What's the other one? Otherwise, it's not going to hit home. But like schedule, quality, and cost. That was the other one. But you can only pick two.
This question feels like that a little bit.
Yeah, so it's kind of like that. It's like, well, dang, I definitely want it to be performant. I want it to be quality. I want to deliver it on time, and I would like to deliver this solution under budget or on budget or whatever. But I mean, when you're talking with engineers, it's kind of difficult to optimize all three of those variables across whatever it is you're developing, right? So man, I would have to edge on or like focus in on quality first. Like let's make sure it works. And then make sure it's dependable. And then make it easy to use. Okay. You know, make it easy for the next person to pick up, even if it's, and I think we'll get into this later on in this discussion, talking about validation, post conditions, preconditions, those type of things. Yeah. Just make it kind of work out of the box. So, and DB Darrell, he's chiming in on the conversation saying he's a fan of a simple first, then documentation. I'm getting to the point where maybe if the Terraform is so easy to use and implement, you don't even need the documentation. But me, honestly, if I'm when I'm I know, right? When I'm putting together a module that I know other people are going to be using, I'm automating the documentation in a way, and there's tools that will help you do this, that you push your code and it updates the documentation for you automatically. So it lists, these are the inputs, these are the outputs, these are the resources that get created. This is what the example looked like, which is another thing that Jim talked about in this chapter. Every good module should have an example that people can refer to. When they pick it up, they're like, how do I even wire this thing up? Okay, well, here's an example of how we recommend you use it. And maybe it's not a best practice per se, but this is how, how you connect to it or how you implement
it. So you mentioned the example folder under that they talked about in the book. And they go into different examples. Basically, so for rolling deployment, you can test it out with one instance. You can try it with auto scaling, with a load balancer, with custom tags. Just the idea that the author of this imaginary module had the forethought to include examples on how to use the code that they wrote. And that's actually not a bad idea. And if you go down the page 293 a little bit further, Angie Jones would be very happy that I'm going to be saying that think about test-driven development, like not even writing, just getting at the keyboard, writing all the code down, but rather think about how you're going to test it. And that kind of forms your opinion on how to create said code. So chapter 9 will go into that. And I thought about her when I read that, because that's her jam. And when I read it, I'm like, ain't nobody got time for that. Like that was the first thing I thought. But there is some merit to it. I won't discount it. I won't discount it.
No.
What do you think?
Fair enough. No, I agree. Like, well, I mean, if you're talking about testing, definitely. Well, for Terraform too, if you really want to test this up, and I think we'll get to this, like you said, in the next chapter, because they really go into testing quite a bit, because you're actually creating a thing. It's not like in with a functional programming language or a high-level programming language. You can mock a lot of things. And I guess it is easier with Terraform now because you can use local stack or mini stack. And there's some new ones that are coming out that are really cool, where you can emulate all of your cloud resources and test against that. But it's not simple. It's not like something that you can do out of the box and easy. So yeah, it's like people may run it. They may run the plan, the format, validate, hey, it's good. But then you can get into these funky situations where, your applies don't work because you did something funky in your configuration. Well, that's kind of a gotcha. And there's ways to get around that with testing, with validation, with preconditions and post conditions. But I think for practitioners, cloud practitioners that are writing infrastructure as code, testing is probably not on the very top of their list. Well, even in Jim's list, it was at the bottom. It was the last thing. It was the last thing after documentation. So I don't know if that's if that reinforces the thing, but yeah, it is what it is. I think testing is needed, but it's not the first thing on people's minds when they pick up an infrastructure as code project.
For IAC, absolutely not.
Yeah.
Absolutely not.
Yeah.
So if the section did go into, like you mentioned, validating preconditions, postconditions.
Yeah.
And have you ever used that methodology?
Yes, I have.
You have.
If ever I have a case, and again, this is where you're adding quality and reliability to your module, particularly with validations. I feel like if ever you have a module that you intend for other people to use, you should add validations to your variables because it's free. It's really easy to use.
How about that?
If you say, hey, number one, set a type. This variable should be of type string, type number, type list, type map, or whatever.
Right.
It does that for you for free. And then you could add this condition, which evaluates to true or false. And you could say, hey, this needs to be a number and it should be between 0 and 100 or something. So if somebody puts something in there crazy, because, and I'm sure you've seen these memes before where product managers watch people using the product that they've developed in a totally different way than, when they're like, yeah, put the circle in the circle hole, and they're like trying to put it in the square hole or whatever the case is. No, so you want to put these validations in place for your module inputs that prevent people from trying to tweak or use your module in a different sort of way. Gotcha. So yeah, I've definitely used validations to reinforce the way that the module should be used.
And there are examples in here when to use them. So if you haven't given it a try, locking it down to a particular type is definitely like 101. You should always make sure that the information that you're expecting is in the form in which you're expecting it. But it also gives you examples for when to use pre and post condition blocks for checking assumptions, enforcing basic guarantees. So yeah, that's built in. And like you said, it's free. You should definitely take advantage of some of that functionality.
Yeah. And he does go on to the point where for testing and for building in these validations, the preconditions, post conditions, that Terraform still has limitations in the way that these are applied.
True.
And that's where you go into the more robust tools like TerraGrunt, and maybe some of the others, which we'll discuss in the next chapter.
They have OPA, and those two tools we talked about in the next chapter. So more to come.
More to come. Join us next time. And I forgot to use penultimate. This is the penultimate episode in this season. Next season, when we wrap up with the finale, we'll be using we'll be talking about all the testing and using Terraform as a team. So yeah, be sure to stick with us, keep rocking with us to the end. We're gonna wrap it up.
Please.
But yeah, this is my opportunity to use penultimate.
That's the word. Yes, that's the $5 word. So you snuck it in there. I'm glad you did. So for everyone who is on now, we have a lively bunch that's checking in and listening to us. Next week we'll be wrapping up Terraform up and running. So are we going to talk about later in this stream? Are we going to talk about asking for suggestions?
Yeah, I think so.
Okay.
For sure.
Okay, very good.
And for sure, I mean, we're kind of not say breezing past. We're giving this is due diligence, but I do have a demo after the end of this discussion. So hang tight to talk about validations, preconditions, post conditions, and version modules, which was the next topic in the chapter we were about to get into.
This is right on time.
Yeah, we are right.
Is it right on time for your demo?
Well, we can get through these next few points, and I think the demonstration will hit that much closer to home after we kind of discuss some of these topics.
Let's go. Okay.
Yeah. So, well, after the testing or testable modules, he talks about version modules and the three very specific dependencies that you have when you start to develop and share modules. The version of the Terraform binary that you're depending on, the providers that your code depends on, such as the AWS provider, and then the module itself or other modules that this module depends on. So you have these three very, very specific variables that can change across your project's lifecycle, and you need to pin them down or at least set a range or something, because again, you want to make it you want to make your module usable for people, and give them a heads up. They could be running Terraform like beta 1.0. And you're like, wait, friend.
You got a warn assistant.
Yeah. Like, I know you're just getting started, but I would encourage you to increase your Terraform version to this. Or they may be like on the super cutting edge. They're in Terraform 9. They're coming from the future. And you're like, hold up, wait. I know you have a DeLorean that covers time and you can move back and forth between time and space. But we're operating between Terraform 1.14 and anything less than Terraform 2. So it protects people from doing anything crazy that way. The provider is also a different story. There was a big or similar story, but different point. When AWS provider changed, there was a big jump in the way that they the API, or the way that Terraform interacted with the AWS provider, in the AWS API, where people were stuck on providers. They couldn't advance. If they tried to advance, they were breaking features. So they really had to pin down on the version that they were using, the version of Terraform and the provider as well, just to make sure that they could keep working the way that they wanted to. So without getting automatically updated and causing problems that way. And then the last one, modules, and we talked about, I forget which discussion it was in, but using Git tags, Git SHA, very specific, tag nomenclature to determine which version of a module you're pulling into your code. And like I said, I'll show these in my demo as well.
So if you're reading along, when he's talking about versioning and pinning it down, there are examples for, the setting the, what's the word he used for, why is it escaping me? There's a phrase used for when you're saying you want your Terraform to be at a certain version, right? There's a literal term for it.
Like pinning it?
Not pinned, but it'll come back to me, or it won't, whatever. But let's not lose this thread. It has to be in here. I don't want to get turned down. I hate when I go down this little rabbit hole. But anyway, pinning your versions, very important, because like you said, you want to make sure that later dev, other dev, when they look at this code, they'll know that this works in this environment with these particular versions, because we see that things change so much. Provider features change a lot. Even the modules that you're creating, you're always iterating on them. Those are different versions of that module.
Yeah.
It's just best to pin it down. And that term has not come back to me yet, but I'm sure it will. I'm sure. And I didn't, maybe I highlighted it in the online.
Oh, in your online version. Yeah.
I'm still looking. So.
No, okay. Well, while you're looking, I guess I'll move on to, because we'll put a pin in pinning versions. See what I did there?
Yes, we will.
But the next point he talked about was going beyond Terraform modules and using these other capabilities that Terraform has, so that you can work around some of the limitations of Terraform, such as a missing provider, like a way to do some sort of complicated logic with your plans and applies and so on. And the topics that he covered here are provisioners, the null resource, and the external data source. I have used all of these, and I have opinions. I don't think it's enough to break out a pulpit or a soapbox.
Okay.
I do have opinions.
Just drop a little knowledge. That's all.
Yeah. So for provisioners, you got the file provisioner, which lets you copy files or directories from where Terraform is running to some other resource. You've got the local exec provisioner, so that you can run commands on the local system as part of your Terraform apply. And then you've got the remote exec provisioner, which lets you run commands on some remote system during your Terraform apply. Now, they're all capable, but I just feel like anytime you reach for a provisioner during your Terraform run, it just makes me feel wrong. Like something feels off because you're in this Terraform process and you're handing control over to something else. And it's fraught with with dragons, like potential for error, and even like setting it up, like local exec. How do you know where your Terraform is going to be run? Is it going to be run on a Linux system, a Mac system, Windows? Is it going to be run with the proper credentials for whatever it needs to do? Like, can it access the file system or the file path that is the command even going to be installed? You know, so that there's a problem with that with local exec. And then remote exec is crazy because you're setting up permission over SSH or maybe some other method. And then so you have to set up whatever environment you're running your Terraform in to have access
to be talking
to those
to somebody
credentials.
else.
Yeah. And it's like, man, come on. Like, why do you want to add that additional layer of complexity
when it's not needed?
When it's not needed, when you can unbundle that and deploy the code, and we've talked about this before, and then use like a secondary process to configure your application, your system, whatever, with a tool like Ansible. Ansible keeps coming up in conversation, but Terraform and Ansible are buddies. Terraform goes in, it lays the groundwork. It says, hey, this is how we're working. And then Ansible says, okay, I got you. I'm going to configure this. I'm going to set this up. I'm going to install this. Boom, 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 boom. You run Ansible again. Ansible's like, hey, you're already good. You know, I'm idempotent. You know, I'm not going to do anything else because it's already done. And it just backs off. And some of that, some of those conditions are also errors with provisioners because they're provisioners that are only run once when the resource is created. So if you need to run those provisioners again, like you have to destroy that resource and recreate it. So that's kind of a problem as well. So anyway, I did do some research on this one, and then I'll read this one thing and I will remove myself. I did get my pulpit out. I will step down after this. Yeah, right. This is directly from the Terraform documentation.
Okay.
Directly from this is what they say. I'm going to read this verbatim. Warning. Terraform is primarily designed for immutable infrastructure operations. So we, Terraform, strongly recommend using purpose-built solutions to perform post-apply operations. When you are unable to use a purpose-built solution, you can use functionality built into Terraform called provisioners. So even before they mention provisioners, they say two things. Number one, they say warning. They say, watch out.
They got your attention.
They say, well, three things. Terraform is designed for immutable infrastructure operations. Whenever you're running these provisioners, it's not always immutable. You might be changing something. And then they say, use some purpose-built solution, maybe like an Ansible, Chef, Puppet, so on, for these post-apply operations. And they're like, hey, if you can't, you know, we try to warn you, if you can't do all these things, then maybe you can use a provisioner. But like I said, it just, whenever I look at a provisioner, I'm like, I feel some kind of way about it.
So you do have choices, but best practice is leave the idempotent part of the configuration where, like you said, where Terraform is laying down the foundation, and you come in with a day two type of tool that is purpose built for this next step in your development cycle, in your life cycle. So don't try to squeeze too much in, just like inside of Terraform code. Don't try to squeeze too much in. But in this example, I could see where that can get really messy, because that's not, I don't know if that's its initial sweet spot. Like it can, but shouldn't, you know? So that's a good way to think about it. Just because you can do something doesn't mean you should, when there are other tools that are purpose built for it.
So then after that, he goes into provisioners with the null resource. And the null resource is kind of cool because it doesn't create a resource. It's a resource that doesn't really do anything, but you can use triggers to cause this resource to be activated during an apply. And the way he demonstrated this is with the UUID function. So every time you run apply, this UUID is going to be generated. So that means this resource is going to have to run through its life cycle. And so every time this resource is created, it's going to cause a change to happen either a destroy or an update or something like that. And so then you can run these provisioners every time you run Terraform. And it's kind of cool with null resources. You can put stuff in there that you might not want associated with a live resource. It just kind of like hangs out with your code, but it doesn't really do anything. And I've seen it used in a couple ways like that. But
give me an example.
I'm trying to think of one. Updating some sort of log or system to say, hey, this plan has run, or this apply has been applied, or something like that. I'm trying to think if there's another way that I've used that one.
That's okay.
Can't recall.
Don't waste anything.
That's the first one, that I came up with. And then the last one was external data source. I don't particularly care for this one at all. Out of the box. Because I feel like if Terraform needs to get some sort of information, it should be provided as a variable, or wherever the Terraform apply is running, it should have permission to access a parameter store or a secret store. Gotcha. That's a defined location to hold this information, that it could pull it into its apply, versus having to run some command, which again, as I said, could be fraught with difficulties of permissions, binaries being available, Windows versus Linux, et cetera, et cetera, et cetera. You never know out of the box where your code's going to be running or how people are going to be using it. So I would say, I would say stay away from it.
Okay.
And even there, and this was a quote from the book, from my notes. Jim says, be conservative with your use of external data sources and all of the other Terraform escape hatches, talking about, these no resources, provisioners, since they make your code less portable and more brittle. So that pretty much sums it up right there.
Yeah, it does. So yeah, you've been warned. Just because they're there doesn't mean you should use them. But if you needed that functionality, Terraform can apply it. All right. So we just went through provisioners, null resources, local exec, remote exec. What else?
Well, that pretty much, it brings it to the conclusion, and I'm ready for my demo.
Oh, okay. Wait.
I take it back.
At the end.
I'm not ready for my demo.
All right. Well, it's okay. It's totally okay. So there is always a conclusion at the end of the chapter. And the author talks about, now that you've seen it, the next time you begin to work on a new module, use this following process, right? So he's developed sort of like this framework. So go through the checklist that Michael mentioned earlier, right? And identify the items that you'll be implementing. And then create examples, right? So this is this TDD a little bit. Write that example code to define what you think the user experience should be using the code that you just wrote. And then it says create your modules, right? So you want them to be small, reusable, compostable, right? Those are the words that we've been hearing. You can use a combination of tools, right? So it doesn't have to be all Terraform, but Docker, Packer, Bash to help you implement these modules. Make sure you're pinning those versions down. Pin them down, including Terraform Core. And then create a test folder and write automated tests for each example. All right. And that last bullet point, testing, is what is touched upon in Chapter 9. Chapter 9 is called How to Test Terraform Code. Look at that segue into the next chapter.
I know, right? And I'm even ready with a banner there.
What?
And we're also going to be going into Chapter 10, how to use Terraform as a team. But definitely looking at the tools and sort of the the stuff that goes along with testing Terraform code.
All right.
But we're not done.
Waste enough time for you to
You did that. You know what, Angela? That was perfect. I couldn't have asked for a better segue or time, a little hand waviness for me to get set up
You're welcome.
to get my session ready for this demo. And we, like we talked about, Jim, the author of the book, he did a good job of walking through the steps you need to refactor the modules that we showed before into something that is more production grade.
Did you say it was a good example? Is that what you just said?
I said it's a good example in refactoring.
Okay. Yes.
Yeah. If I didn't say refactoring, I meant to say refactoring. Okay. It was a good example in refactoring. However, I did not want to go through the toil of taking code that was working before and mucking it up to work in the way that he wanted to demonstrate for these particular points. So in a session with my good friend Chat, I said, hey, let's look through these notes that I've taken
very good
on this particular chapter and come up with some demonstrations, some examples where we can talk about the points themselves without having to go through all this refactoring. So if you want to follow along with this demonstration or see the code, I'm actually sharing my screen right now for the folks of us who are listening. I'll do my best to describe what I'm doing. But if you miss my description, you can catch the replay on LinkedIn, YouTube. I'm not going to say Facebook, MySpace, etc., because you can't find them there. But check out YouTube and LinkedIn for sure. But if you go to GitHub, manage chaos / Terraform validations - conditions, you'll find the code that I'm using here.
Okay.
First thing he talked about was version pinning. So I did pin down all of the code that I'm using in this particular demonstration. I set a required version for Terraform. It has to be greater than or equal to 1.14, and it has to be less than 2. I think the current release of Terraform is 1.15 something. So I was like, let me go 1 version back, but definitely be less than 2 for my version of Terraform, the binary. The other variable that we need to pin is our providers. So this particular module, the root module, and some of the submodules, they use the HashiCorp external provider, or a provider. It uses the HashiCorp null provider, and then it uses the HashiCorp random provider. Mm-hmm. So I have all these pinned with the equal sign to this particular version. Like no other version shall be used with this project. Yes. So otherwise, you're going to have to, create a branch, run your test with the new version or whatever, and then do a pull request to approve to make sure we can update it. That would be my recommended flow for that. Okay, so that's the versions. And then he talked about pinning modules as well. So for this particular example, I brought in a module from Cloud Posse. Mm-hmm. It's just a very simple module. All it does is create a random number every time you run Terraform apply. But it lets me show you how I can pull a module into a submodule into my root module. Idea. And I can pin the version very specifically to this particular one, version 3.0.1. So again, if I wanted to increment this to the latest version, I would have to explicitly go into this code, and I would suggest make a branch, make the change, run your test, pull request, and then talk with your team to merge it into your code base. So that's the Terraform pin, provider pin, and module pin. Got those covered. So now let's talk about how we pulled all this stuff together, or how we pull it together. So in the main.tf, which I'm displaying now, I have an external data source. All this thing is doing is it's basically taking a value from standard in on the command line or as a variable, and then printing that value back when you run your apply. Very, very simple external data source example. I'm sure I could come up with something a little bit more complicated, but time, it's a limited resource. Next up on line 8 of this code here, we're looking at the null resource example. And he showed this in the book. This is the resource that gets created, but it doesn't really create anything. And it's good for this type of example because I don't need any credentials to run this example. I'm just running pure Terraform on my local system. It's not going to deploy anything, right? So if you're following along, you can totally run these steps just the same on your system. All you need is Terraform installed. The trigger for this is the UUID and also the environment. So if the UUID, and it's going to change on every apply, or if the environment changes, then this would also trigger the lifecycle for this particular null resource. Speaking of the lifecycle, I have a precondition on line 19 and a postcondition on line 26. The precondition is going to check, and this is a variable, just random variable that I'm passing in minimum replicas and maximum replicas, but it's enforcing the case where the minimum replicas has to be less than or equal to the maximum, because you don't want your minimum to be 1,000 and your maximum is 2. You know, it's flip-flop. You know, it doesn't work that way.
Got it.
Post condition, it just makes sure that the environment that's set for this particular resource is the same as the environment that you passed in. So I don't know, something else could change along the way, and all of a sudden this variable that's passed in doesn't match what this resource is expecting. And this would be after the apply. And this is representative of something that maybe AWS does some change, or something happens that you're not expecting. And then you can check that value and say, hey, this, you know, I was expecting 3 subnets, but I only got 2. So I need 3. And so it doesn't match what I think should be happening. And then you can cause a failure based on that. Post conditions run after the apply, preconditions run before the apply. That's, I think, the thing to note there. Then on line 32, I got a local exec, and really this is a very simple example for a local exec. It runs an echo saying hello world. It does use my local command uname to get the basically the name of the operating system that I'm running on. So this command would probably work on Mac OS. It'll probably work on Linux. It probably will not work on Windows if you're running in a native PowerShell or CMD session. It would probably fail. I'm not going to demonstrate that today, but I will leave that to the listeners and viewers to try that out on your own Windows systems. Okay, so we've gone through all the code. Let's run some of this code and see what happens. So the first thing I got to do before I do anything in the Terraform project is init. And I will say I have a make file that'll do all this stuff for me, so I don't have to type all these commands. If you're following along, go to the repo, and you can find all these files, and you can see the underlying Terraform commands that I'm running. You might even see them on the screen if you're watching. I'm not going to type all those commands out because I forget what the switches are and stuff. So I have them baked into this make file. First thing I got to do is initialize my project. And because I have set versions for this particular project, it's downloading very specific versions. We saw version 301 for that Cloud Posse example, and 390 for random, so on and so forth for, you know, external, null. So I've got those very specific versions. If you run this on your system, you're going to get those exact same versions too. Okay, so now I would run a plan. And for the plan, I'm going to create 2 things. Well, let me go all the way to the top of this output. The null resource is, again, it doesn't really create anything, but it's going to be quote unquote created. And we can see that my environment is set to development because that's the default value for that. And then the UUID, it won't be known until after it's created. So I won't know that until after it's applied, but that's the trigger that kicks off all these lifecycle rules, right? And then this Cloud Posse module, all it does is create a random integer. So all this stuff is going to be created. It's got some configuration, minimum, maximum, and then the result of whatever it does will be known after we apply. And then we get some outputs too. We're going to see the hello world is just set to the default. We can play around with that here in a little bit. The environment and the UUID. So let us make, let's see some of the invalidations or the validation work first. So I do have validation. I'm going to pass in an invalid value. Okay, so I think for the validation, the only values it could take are like development, staging, and production, and they have to be lowercase. Oh yeah, right there. There is actually on the screen. Since I passed in foobar for my environment,
it said
I get an error. It's like, hey, I'm not going to let you even run this apply because environment must be development, staging, or production. So and it tells you exactly where it says this was checked by the validation rule at variables.tf line 13, characters 3 through 13. So it's very specific on how you can find that. Okay, so now let's see a precondition failure. Precondition, because I don't have make type properly. Precondition failure. Okay, in this case, let's see. It looked like the plan was good because it's like, hey, everything's great here. But then it failed because I set var.maximum replicas to 3 and minimum replicas to 5. So this is swapped. I probably meant to say my max should be 5 and my minimum should be 3. And it goes on to give me the error message: minimum replicas cannot be greater than maximum replicas. So that's my bad. I need to go in and fix that, and then I can run it.
Okay.
So after, let's say I do that, and let's look at the post condition success. If I run that, everything works. My configuration should be valid. Let's go up here and see if I can see that in the code. No, it's not going to show it to me the way that those variables are set. But here, everything's good. We see environment set to production. We get a UUID in the output.
And you also see the module example where it generates your random number.
Yes. Yeah. The module example right there. We get that. And yeah, the one thing I didn't show or meant to show was you can also see the version. Terraform version will give you the version that you're using. So this lets me know I'm within my providers. If I was or my Terraform version, required Terraform version, if I wasn't using 1.14.8, something greater than 2 or less than 1.14, then it would give me an error. It's also showing the version of the providers that I have installed. And then I can also show make providers. Let's see. It's just another view. If you run Terraform providers, it'll give you another view of the providers that are installed in this particular scenario. And then I think I had one other one. It's just another apply that'll show you a valid application. Showing how, again, that null resource, I'm destroying it, I'm adding it back because it's changing every single time. And then we get, in this case, the environment, I changed it to staging, and we get a different UUID. The module example, the random number stuck. I'd have to look at that example to see, what causes that to be stuck in that particular state. But for that null resource, because we're generating a new UUID every time, it's running this particular trigger. So it runs that local exec, or not the local exec, it runs the lifecycle, which runs the pre and post conditions every time that resource is modified.
These are good examples.
I think that pretty much sums everything up for me. Yeah.
Nice. Good job.
I had anything. Thank you very, very much.
Very good job. Good examples.
Get that out of the way.
That was it.
Yeah, that brings us to a close. I'll put the I didn't put the banner on the screen as I was going through here, but if you want to follow along, run these examples for yourself on your own system. I have displayed the repository on the screen.
Fantastic.
And I'll add them to the show notes for folks that are listening and want to try to find that for themselves.
Awesome. Don't make them work for it.
I will try to make it as easy as possible.
All right. Well, that brings us to the end of chapter 8, production grade code and production grade Terraform code.
Terraform code.
We're talking about Terraform specifically. And it went over, this was a really chocked chapter. It talked about understanding how difficult it is to do production grade code, how we tend to not understand the vastness of some of the tasks that need to be done. It goes over the reasons why it takes so long to build production grade code. Yak shaving, if you haven't heard that one. I've heard that one before. It gives you a checklist, and it does reference the checklist later on in the chapter. When you're looking at things to create, make sure that you look at this checklist, and these are things that could possibly be automated. Then he talked about the modules, small, compostable, testable, version, very important. And then it goes beyond the Terraform modules in the book. You didn't go outside. They were all Terraform, right?
Yeah.
Okay. Talked about why big modules are a bad idea. We learned a new phrase, at least I did, called code smell. Um, he went over reviewing all of the different modules, putting examples of how to use your modules is a really good practice. Michael just showed some examples for validation, preconditions, and postconditions, as well as locking your code down to a version. And that was pretty. Oh, and he did talked about provisioners. So that's it. This was a pretty beefy chapter, mainly because, well, I don't want to say mainly, it was a lot of information in it, but like we mentioned earlier, there's a lot of walking through refactoring. And I don't, you probably remember, if it wasn't last week or the week before, where I had refactored, copied and pasted code which this way in the third, and then I'm like, oh gosh, I just made all these changes. Now I wasn't doomed, because I did have it on my local machine, but be careful, right?
Yeah,
that's why we didn't have any code really from the chapter, because it was too many moving parts. A suggestion for him when he upgrades to the next version is to make sure that each chapter has the full code. And I don't know if that's the right thing I'm saying, but
no,
the refactoring part of it was helpful, but it was messy. It was, you're trying to keep track of all of these moving pieces. I don't know how you can improve upon that. What do you think?
Well, I would recommend like 2 directories per chapter. One is like the starting point, and one is the finish. So it's like you start here and this is the solution, or this is the completed code, or this is the updated code. So you, as a learner following along with whatever the author is providing, you can start in the starting state directory and start to work your code, and then maybe diff against what he's doing. Like if you get stuck, you're like, yeah, what did I do wrong? I followed all the steps. Something, got kind of buggy. Let me look at his solution. Then you look at it like, oh, okay, I forgot to do this thing.
Yes.
So you can go back and, fix it in your code. Or if you just want to like blast through, drop down into the solution directory, Terraform init, Terraform plan, Terraform apply, and you see the solution out of the gate. I would recommend that if you're really trying to get that hands-on keyboard muscle memory. I know this stuff. You got to work it. You got to.
Yeah.
I mean, maybe you have to do that refactoring to really get it to stick. But I would hate for people to get stuck and not have a solution that they could fall back on.
Yeah. I agree with that 100%. Yeah. So that's it for chapter 8.
Yeah. Next
chapter
up,
9 and 10.
It's chapter 9 and 10, how to test Terraform code.
Gosh.
Chapter 10, how to use Terraform as a team. And then we'll be landing this plane.
Yeah, this
winding
is like,
down this season.
This is like 100 pages to read.
It's a lot of now, okay, please give me some grace when I put together this plan, because I did not look at the page numbers to say, like, I was just like, you know what, we'll wrap up 8 episodes, we'll cover chapters 9 and 10 at the end. And then here we are looking at these chapters and we're saying great day in the morning.
Baby, I should take the week off.
Yeah.
And just like, that's 100 pages.
That's a lot of reading to get through in a week.
That's a lot. Well, thank goodness for the audio version.
Yes.
If you're listening to this book through O'Reilly, because they have an audio book version. Why is chapter 8 chapter 15? It is not numbered properly. It is very confusing. So there is no chapter 15. Not in this book, but if you're on the book inside of O'Reilly's platform and you want to listen to the audiobook to hear chapter 8, I had to go to chapter 15. So I'm going to assume if you have O'Reilly, if you want to listen to chapter 9 and 10, you're going to have to go to chapter 16 and 17. So just a little nugget there for you. This book is also an audiobook form on Audible.
Yeah, and that's what I'm using.
That's what he's using. And Yeah, the book, they have ebooks, they have real books, but I don't care what it is, it's 100 pages for chapters 9 and 10. So buckle up, Buttercup, because we
I
landed
know,
this
right?
plane.
Yeah, make sure you, before you start reading, like stretch a little bit, maybe, you know.
Grab a drink.
I know, right?
Grab your readers and a pen and a piece of paper so you can take notes as you go.
Yeah.
Because, yeah, you're going to be in for a minute.
It's going to be a lot to cover, but I'm looking forward to it because I've never used TerraGrunt before.
Hey.
I've never used TerraTest. So I'm looking forward to seeing how these tools are applied.
Awesome.
Really excited for that.
Fantastic. Well, thanks, everybody. Thank you for listening. Thank you for the people who were rocking along with us live. Thank you to the people who caught us on a replay. Thank you to everybody. And thank you to you, Michael, for
thank
making
you, Angela. I do appreciate it. Thank you for all of your insight and wisdom. It's always appreciated.
And you like to read. And I think this was like the perfect combination, like Stacey Lattisaw and Johnny Gill. Like,
there you go.
This is what we're doing here.
Right.
You know, this is the perfect combination. Google it when you get home if you have no idea what I'm talking about. But I love the fact that we do this. This is just, I get so much enjoyment, and I learned so much, like from you, from the book, from the questions, from your answers. Yeah, this is a good time for me. Absolutely. And I hope it's a good time for our listeners.
Yeah, I have to agree. For me, I'll speak on behalf of the listeners that yes, this is a prime time focus for learning in a fun and shenanigan-filled way.
There's no other way to do it.
It's a good time. Whenever we can get the book and get to the code, hey, I'm there. It's all good for me. So yeah, with that, thank you all for joining us, and we'll see you on the next one.
Thanks, everybody.
Bye.